All right, hello, ladies and gentlemen. Welcome to lesson 8.2. In this lesson, we're going to be multiplying polynomials. And overall goal here is that we are going to be able to multiply any form of polynomial by any form of polynomial, meaning that we're going to be able to do binomials times trinomials, and we're going to do monomials times trinomials, etc., until we start getting beyond monomials, binomials, trinomials, and just any type of larger form of polynomial. We're going to be able to multiply those things by the end of the lesson. So let's get into it. Before we look at an example, I want to remind you of something that you did really like back in third or fourth grade, back when you first learned how to multiply two numbers together. And that is to think of multiplication as an area. What I mean by that is when we do 2 times 4, what we're really doing when we think about it in terms of an area is that we are creating a rectangle. So if this side was 2 and this side was 4, we have a 2 by 4 setup. And so when we think of multiplication as an area, this is 2 times 4. There are 8 squares that makes. This, by the way, is reasons why we have, why they call like certain numbers the square numbers. Because when we take 3 squared, we're doing 3 times 3, which if we set up as a rectangle, in this case a square, we get 9, right? And that's why 9 is considered a square number, because we are multiplying. When we multiply, we can think of that as an area model being created. Now, what we're going to do when we're multiplying these together, we want to think of it as an area again. The problem is we're not dealing with a whole number. When we do something like 3x, this is a multiplication problem, 3 times x. We're taking 3, which is like this. We need 3 of those. And we're multiplying it by some length x, and I don't know what length x is. All I know is that I have 3 x's. Whatever length that is, this is 3 times x, and this is some length long. We're going to be doing that when we multiply these monomials and binomials and trinomials together. So I want us thinking about the area model that gets formed when we're multiplying whole numbers and variables together. So let's look at our first example here. This is a monomial times a polynomial, right? Notice that there's 1, 2, 3, 4 terms here. And so we don't have a name necessarily for a 4-termed polynomial, so we just call it polynomial. And I'm going to multiply these two things together. Now, we can just do what we've done in the past, which would be to distribute. And distributing works just fine. I can take this, and since it's outside the parentheses and I'm multiplying, I'm just going to distribute the 2x cubed into everything that we have here. And you end up with 2x, and then this is x cubed times x cubed. So if you remember back to our last unit, that means x to the 6th, plus 2x cubed times 3x squared. That's 6x to the 5th. And this is 2x cubed times negative 2x. That's negative 4x to the 4th, because it's 3 plus 1. And then finally, 2x cubed times 5, which is positive 10x cubed, right? So distribution is fine, right? We need to remember our exponent rules. But again, I want to show you this in terms of this area model that I was talking about, because it's going to really help us in some of our future problems in understanding those things. So I've got one side, 2x cubed, and then I've got 4 terms up here. along the other side. And we've created an area in between. But again, it's so hard to describe what this area is because it's variables. But what we can do is kind of like separate these into boxes and just multiply these pieces together. So 2x cubed times x cubed makes the 2x to the 6th. And then this makes the 6x to the 5th. And then this makes the negative 4x to the 4th. And then this one makes the 10x cubed. And when we do this as a monomial times any kind of polynomial, these four terms in here that we get are our solution. 2x to the 6th plus 6x to the 5th minus 4x to the 4th plus 10x cubed. Now, this area model might seem kind of silly on an example like this, but it is going to be really helpful in our next set of examples coming up here. So that's everything for this video. I've got a question for you on your notes that I'd like you to do, and I want you to do the area model here. You can do the distribution as well to check your answer, but I want you to try and draw this area model first off to help us kind of like get this understanding of what we're doing when we're multiplying these things. And then, yeah, do that problem, and then you can check out the solution in the next video.